Okay, what we've got here is a short screencast of how to use some of the functions within spreadsheets to do a lot of the work for this project. You'll notice that I've got all my original data here, and this is the data that you've been given, and I've just made a copy of it, so it's been copied into my drive so that I can play around with it. If something goes wrong, I can always grab the original data again. You'll have to work out the sample size. Once you've worked out your sample size, then you can go through and pick your sample. I'm just going to demonstrate by just grabbing some numbers and showing you how to work. So I'm going to pretend that my sample size comes down to about here, to about 20. I'm just going to copy that, Control C, and I'm going to go into another sheet which I've just called sample, and it's just for me, so that I can have my sample here and my original data back there if I need it. Now, I don't know if my sample is appropriate, so I'm going to work out what the average of my sample is. Remember we talked about your average, your sample mean versus your population mean. So all you have to do is go equals, and this equal sign here tells the spreadsheet that you're going to put in a formula. So I'm just going to use the word average because it knows that word is, and then I'm going to highlight the cells that I want. And notice how it says A4 to A20, so it's going to find the average of the numbers in here. If I put a bracket at the end of it, it'll work out the average there for me. Now, I have to do it for all these ones. However, when you move your cursor down, it turns into a cross. If you drag it across like this, it'll just copy the formula down, and you don't need to worry about that. So I've now got my sample mean for all my numbers. If you wanted to make it only 2 decimals, you can come up to Format and go to Number and go to 2 decimal places, and it will just do it for you like that. Perfect. Now what we need to do is to check our sample means against our population mean. So we're going to go back to our original data, scroll down to the bottom, once again put in the word equals average, and then you want to highlight up. So you click on that first cell there, hold down Shift, and just scroll up to the top of the page. And then when you get to the top, you just push the button again, make sure you're in the right column there, and it will then highlight all those cells like that. And then put a bracket on the end of it, and away you go. So it works out the average from A4 to A903. I'm going to format this to have 2 decimal places, and then I'm just going to drag it across. Beautiful. The middle one goes divide by 0 because there's no data there. So this last line here, which I'm just going to make bold, is my population mean. So the first one's 0.5. My sample mean is 0.57. So that's not it's not that close enough. 0.49. I've got 55. So you can see that my sample isn't big enough. But that's just for you to do. Now, what you want to do now is you want to work out Pearson's correlation coefficient, the strength of determination, which is R squared, and then you also want to draw it in the line of best fit. You can do this inside this spreadsheet, inside the Google spreadsheet, but it gets a bit tricky because you've got to write a whole lot of formulas. Excel does it really well. So what I'm going to do is I'm just going to highlight these cells here and do Control C. Now I'm going to go and open up Excel and grab a blank sheet in Excel. Looks exactly like this. And then what I'm going to do is I'm going to, there we go, that fits a bit better. I'm just going to paste in what I've just copied. So it's Control V. And you can see I've got all my data there. Looks great. So I've got my average weight of the chickens, my lifespan, my protein, that kind of stuff. I want to draw a scatter plot of this and draw in a line of best fit for this. Then I want to draw a scatter plot for this, draw in the line of best fit for this, and if I could find R and R squared and the equation of the line, that would be fantastic. So all we do in Excel is just highlight it, just holding the mouse key down, and then go scatter plot and put in a graph. So you're going to go, on your version you'll have insert and then chart, or insert and graph, and then you pick a scatter plot. And what it does for us quite nicely over here, oops, it's not going to do what I want it to do. There we go. It gives us a scatter plot of the data that we've got, and you can see that it's actually plotted. It's got the scale up here, it's got the average weight of eggs there, and it's got an average weight of eggs there in grams. You can play around a little bit to put in titles and things like that, but that's just up to you. The good thing that Excel does, if I come across to my chart and click in there, notice how it highlights all the dots. If I then just go right mouse click, it'll ask you to add a trend line. So you click on the dots and they all become live. They've got those little dots on the side of them. Go add trend line, and what it does is it'll say, okay, puts in a line of best fit, and it has these options. So these are slightly different I'm on a Mac here, and the Mac version than the PC version, but you'll be able to find the add trend line. We want to put the equation on the chart, and we want to find r squared on the chart. Okay, so to put display equation on the chart, display r squared on the chart, go OK. And what it does, I can just grab and drop and put it over here. We have now got our line of best fit. Okay, we have got r squared, which tells us our strength of a correlation, and we've got the formula for that line. So now that you've got this, what you can do is just take a screenshot of this, of the graph, and put it into the Google Doc that you're working on, because then you can comment on it. Okay, you've done the work, we know it's there. Now, you might want to say, well, hang on a tick, I know that that's an outlier there. What's going on? If this is an outlier hanging out here, I want to do something with it. Notice that when you move your cursor over there, it tells you what the values of it is. So it's 0.73 and 117.98. So if we go here and go, oh look, that's the one that's an outlier. So if we delete that out of there, what that does is it deletes that out. It will then tell us, redraw the graph. We can move that down there. It tells us what our new r and r squared is. Okay, so it's not too bad. It actually will tell us the new version for r squared. Let me just check to make sure that we're good. Tells us the new version of r squared. We also notice that once we start refining our data, we start getting other things out here. And this one here is probably an outlier because it's away there, so it's 95 and 10. So you can come around to here, you can go delete, and go delete, and notice how your r squared gets better, so it's 0.61 now. So you've actually got quite a good trend there. You could probably start making predictions and things like that as well. You'll probably have 120 pieces of data, so you might be able to work out which ones to take out, but you've got to be able to justify what's going on. The same process is what you do for this one here. I'll do a really quick one of this. I highlight the data, I'm going to do a scatter plot, insert, scatter plot, and notice how I've now got another graph down here, and that the trend is going the other way. And there's going to be a line like this. Click on the dots, right mouse click, add trend line. I want to have my equation and the values on the chart. Go tick tick, draw it in there, move them away from there because it's really hard to read, and you'll find that I've got a line going like that. So you've now got proof that if you give them more protein, they're going to die. But if you give them more protein up here, they're going to get heavier eggs. So your dilemma is to work out where the best combination of those lie.